To start with Unit 3, that is compilers. The topic there, it is a compilers. We are going to see the different phases of compilers. Harsha?
Ma'am?
Is that audible?
Yes, ma'am.
Okay. First, we will see what is the definition of the compiler. Okay, compiler, which is reading the program. Already we have discussed that, which is translating the source program into the equivalent target program. Normally, your target program is your object code, that is your machine code in lower level language, and your source program may be high level language or assembly level language. And the main thing is the translation part, which is going to be done by the compiler. And during this compilation, if there is any error, that is going to be specified by the reported by the compiler. So this is the job of compiler, which is getting the source program and converting that into an object code or machine code, that is your target program. And then in between the execution of the program, if any of the errors are there, it will generate the error messages, that is compilers. One type of translator is called as an interpreter, which will convert the high level language into machine language line by line, that is interpreters. The entire program which is converted means this is a compiler. There are various types of compilers available. For each and every language, is it necessary to have a compiler? That is the main question here. At the highest level, a compiler that is divided into two categories. One is a front end, another one is a back end. Okay, a compiler which is having two phases. One is a front end, another one is a back end. Front end, which will deal with the input language. That is, it may be whether it may be a C or a Pascal language or C++ language, whatever it may be. If suppose that is going to be considered, means that will be taken care by the front end of the compiler. And back end, which will taking care of the machine code. That is, after translation, the source language, which may be in any language, will be converted into a one output language, that is machine language, that will be taken care by the back end of the compiler. The main problem is for each and is it necessary for having different compilers for each and every language we are going to use, and the different types of machines we have. We have laptop with different configuration or desktop with a different configuration. Is it mandatory to have a different compilers for them? That is the main thing. So that can be solved by to develop a suite of compilers that will be suitable for all types of languages and machines. So the main thing here is a compiler which is having front end and back end. So you have a source language that is going to be uh, getting as an input by the compiler through the front end part, and that will be represented as an intermediate representation. Then that intermediate code will be converted into the machine code by the backend, so that we will get the target or the object language. That is normally in terms of zeros and ones. Compilers which will translate the source language, which may be assembly language or any high level language, into the machine code. Then we will see the phases of a compiler one by one. Compiler which will operate, that is the conversion which is not done in a single step, which is done in different phases. In each and every phase, one transformation will be done. The source language will be converted into another representation in each and every phase. There are two main phases in this compiler. One is the analysis phase, another one is the synthesis phase. So the typical, this is a analysis phase. This is done at the front end part of the compiler, and synthesis which is done in the back end of the compiler. So what this analysis phase will do is, which is breaking up the source program into pieces and creates an intermediate representation of the source program, which is not directly converting your high level language into a machine code. Some intermediate level of code we will get it. So what are all the phases which are available in the analysis is lexical analysis, syntax analysis, and semantic analysis. These are the three major phases. And the second backend part, we have the synthesis, which is mainly used to construct the desired target program from the intermediate representation. So here, what are all the two phases available in this part is code generation and optimization. So these are the two phases available in the back end of the compiler. And then these are all the phases of the compiler. You at the top you have the source program, and we will receive the target program by using the target. So these are all the processes done by the compiler. For performing this conversion, the compiler which is using the symbol table manager and the error handler. If there is any error, error will be generated, and symbol table which is used to store your symbols which are all available in your instructions, so that all the phases can able to use the symbol table. So the first is lexical analysis, second one is a syntax analysis, then semantic analysis. Then after these three, your front end part is over, you will get the intermediate code. Okay, so that is done by the intermediate code generator. After that, you have the synthesis phase, that is code optimizer and code generator, code generation and the code optimization. So then finally, you are getting the target program. So first we will see the lexical analysis. This is the first phase of the compiler. So in that, this is otherwise called as a scanner, which reads a stream of characters and break down into tokens. We will see the example next in the next slide. All the characters which are read by the lexical analyzer or scanner, and it will be break up into the tokens. And each token which is representing a sequence of characters, and one token which is representing one entity. We will see what is an entity or a token, and all the blanks in your given programs are replaced, which are all eliminated. We are not requiring it. For example, this ABC, continuously some characters are given, or only A. Normally we are defining a variable as A or ABC. So this is identified as an identifier. So these are all the reserved words. Only if and return are given. Similarly, you have main, and you have int, int is a keyword. So all the reserved keywords are available. And if it is any number, it is an integer literal. There is no decimal point, so it is an integer literal. And if decimal numbers are there, it is floating point literal. And you have the operators plus semicolon, less than or equal. All these are all operators. Only some examples are given here. You just to take all the operators in each and every language. Okay, which depends upon the compiler. And then the punctuation symbols. So these are all required for specifying the block of code. Opening and closing parentheses, and the bracket for specifying the expressions. Delimiters you have colon, semicolon. Delimiters are also there. Okay, and also a string. Whatever you have given within double quotes, which is be a string literal. And comment which is going to be double slash, single line comment means double slash. Slash star, then list of comments, and then star slash means it is multi-line comment. So which can also be identified. Okay. Normally the comments which are not going to be converted into any of the machine code. And we will see one example. So this is a given example. we are going to store the output of this expression in the position variable. Okay, this is the position variable, and for that we need the two variables. One is initial plus rate star 60. How to find the tokens? The lexical analyzer, what it will do is this is a given instruction available